Let's start with the meeting in order, as I was saying, to respect your own time. So let me first of all introduce myself and the presenters. My name is Franco Asato. I am the training and accreditation coordinator with iRAP, and today I will be the moderator of the session. Our presenters will be Samar Aburad, who is our Safer Journeys lead for Europe, and the Professor Marcos Evrovic, who is the Senior Road Safety Expert of the European Institute of Road Assessment. Just in order to do some housekeeping for all to be sure of what we are expecting for this meeting is going to be a 60 minutes meeting, 1 hour. While on the presentation, I would really ask you and encourage you to use the chat for questions. I will be actively reading the chat and directing those questions to the presenters. You will quickly realize that you don't have the ability to unmute yourselves, but that doesn't mean that we don't want to hear you. We will have an open mic space at the end of the meeting. Okay, then you will have the instructions of how to do it. I will ask you to raise your hand and I will be allocating the microphone to each one of you. And as you have already seen, this meeting has been recorded and you will be able to access it once it's finished through our website, most surely. Okay, so before launching the presentation, we prepared a quick Menti quiz of only one question to share with you as an icebreaker, as to get to know who is the faster and the most intelligent person of the meeting. So what I would need is you to grab your smartphone and to scan the QR code that is shown in your screen. And as soon as we have, I will do it myself to check if I can beat you guys. And as soon as we have a good amount of people, we are going to present you a question. It's simple. The one that answers it fastest and correctly, of course, it's the winner. So let's see. We have, let's expect a little bit more people to join. You are not obliged to do so, of course. So let's launch it when we get to 35 people. Okay, let's do it. Okay, so that's the question. By which year to the latest, the UN member states should have carried their first network-wide road safety assessment? What do you think, guys? Okay, so we have 12 people who answered correctly. The most answered question was 17 for 2025, which is actually wrong because it's 2024. So congrats to those 12 people. And let's see who the winner was. Bill and Elsa, almost head to head. Sorry, they responded quickly and correctly. So congrats for you two guys. And after this, let's keep with our presentation. So I would really love to introduce and give the floor to Samar. Samar, over to you.
Good afternoon, everybody. Or may I say good morning for some and good evening for others. Is my slide on, Franco?
Yeah.
Okay. Thank you, Franco, for this nice presentation. Today, I'm going to present briefly what iRAP does in terms of infrastructure safety and its role towards saving lives and injuries on the roads. Then we will dive into the Road Infrastructure Safety Management Directive and its requirements. So what is iRAP? Probably you all know who we are, but I'll go quickly. The International Road Assessment Program is a charity with a vision for a world free of high-risk roads. It is active in 116 countries, and it provides the tools and training to road authorities, mobility clubs, decision makers, development banks, and road safety stakeholders to make roads safer. The shared success with partners around the world has now led to around 1.7 million kilometers of risk mapping, over 1.4 million kilometers of star rating, and importantly, more than $95 billion of road investment that made safer. Our combined impact is now saving thousands of lives every year. iRAP has 3 guiding principles that align with the UN SDGs and their global road safety performance targets, mainly targets 3 and 4. Target 3 aims that by 2030, I'm sure you know all the targets, but I repeat these two because they're important to our goals. By 2030, all new roads achieve technical standards for all road users and meet a 3-star rating or better for all users. Target 4 aims that by 2030, more than 75% of travels on existing roads meet technical standards that take road safety into account. Not easy, but doable. Many countries have started the work towards these goals. Our guiding principles are very simple, but totally adapted to these targets. Road fatalities are largely avoidable. Road designs can forgive drive errors, and targeted interventions do work. This is at the heart of the safe system. iRAP is a safe system tool. The iRAP star rating tool is a safe system tool. In adopting safe systems, we recognize that, firstly, humans make errors, so crashes are inevitable. And secondly, humans have limited tolerance to crash forces. Therefore, we need vehicles and speeds to work together to make sure that crash outcomes are survivable. This component of survivability of crashes is an intrinsic part of the calculations that go into the iRAP model. The road transport system should be designed so nobody is likely to get killed. Here we go a little bit into more specific components of the assessment. What is infrastructure data? Infrastructure data has 3 components that are part of the road safety performance indicators. Obviously, the speed, the road users' flows, which are related to the mobility modes, and the road attributes that also impact both mobility and speed. Why is infrastructure data important? It is important because data is measurable, because this is the scientific way of checking before and after any improvement to the safe system. And this is how we can measure or check if we are reaching these UN global performance targets. We can use the infrastructure data to understand the level of risk that is built in the road, and therefore to undertake actions that target the high-risk sections. Infrastructure data is needed to understand the mobility needs of road users and to propose safe alternatives, such as encouraging active transport, for example, cycling and walking. Next, what does all this mean for system owners, for decision makers, for infrastructure operators? It simply means that key principles for infrastructure design and characteristics need to be adopted to meet the safe system requirements. These are, in this table, there are some examples, of course, there is much more. We can see, for example, like integrating separations between hard and soft road users to protect them from collision and integrate the various modes safely. This is a component that have the key principle of integrating all road users. And finally, to summarize all of the above, the road assessment programs takes all of these requirements into its process, which is first measuring the road risk, which is part of the assessment and screening of the road, and classifying them into categories from low risk, what we call a 5-star road, to a high risk, and what we can also call a 1-star road, and 3-star is like the average acceptable safety of a road. This screening and classification will then lead to various proposals for investment planning. We aim to improve road quality with this assessment, to improve road quality to make it at least 3-star roads as required by the UN SDGs or better. The program proposes a number of options that are proven to increase the safety of the infrastructure. Over time, the performance of the road is tracked. You can see in the charts at the end, from before to after the improvements, enabling the road authorities or the decision makers to validate the work that has been achieved and address persistently high-risk roads. Next, we will be looking more about the technicalities and the process of doing a network-wide road safety assessment. And for now, that will be it for me. Thank you very much for your attention. I will introduce our next presenter, who is Professor Marko Sevrovic. Marko Sevrovic is a professor at the Faculty of Transport and Traffic Sciences at the University of Zagreb, and a senior expert to the European Commission in road safety. Professor Sevrovic, along with Professor George Yanis from NTUA and experts from FED Engineering, have delivered the network-wide road safety assessment methodology that was published earlier this year by the European Commission to guide the member states in their road assessment program. I will leave the floor to Professor Sevrovic so that all of this are explained in more details. Marko, the floor is yours, or I would say the screen is yours.
The screen. Thank you, Samar, and thank you, Franco, and thanks everybody for joining. It's really a pleasure to see almost 70 people in this call. It seems like our topic today is very relevant for everybody. So what I will try to do today in the next half an hour is to present the RISM directive and their requirements, which came out of the amendments that were adopted in 2019. So probably for those of you who don't know, the RISM directive is the Road Infrastructure Safety Management Directive by the European Commission, by the EU, who is in a sense obligatory for the member countries of the EU. So all of the countries should in a way adopt what is written in the directive into their national legislation and perform the safety management of their roads in terms of infrastructure. So in that sense, the first directive was in 2008, and the amendments, the addition to the directive was delivered in 2019. And one of the main and key components of the amended directive is actually introduction of something that is called a network-wide road safety assessment. In the old directive, we used to have NSM, Network Safety Management, which was basically a reactive method where you traditionally collected crash data and try to categorize the roads based on how much people have been killed or injured on a certain network in terms of also with respect to the ADT and the volumes of traffic. And this was used for the black spot management then. But with the work in road safety, with the safe system approach adaptation in the, let's say, worldwide stage, Also, the RISM directive adopted a little bit, and it said, okay, now we are replacing the NSM with the NWRSA, which is also including reactive, but also a proactive methodology, something that Samar also showed that iRAP also does in its work for several years back. So basically what the directive says here, I did take out the slides up, which shows that this methodology should be a visual inspection. It can be either on site or by electronic means, and it's looking at the design characteristics of the roads or in the inbuilt safety. And also it says that it should be conducted on the so-called TEN-T network, the Trans-European network, and on the primary roads which are defined in this directive. The member states should carry out this assessment, first of the assessments by the 2024, but we already saw that in the Menti question, and that was so it's basically this work is still very quite relevant. And the thing that we will be focusing on today is the provision of the directive saying that the Commission, the European Commission, will provide guidance and the methodology on how to carry on this work. So this has been delivered, and it has been published, and it has been delivered by a consortium led by the National Technical University of Athens, our dear colleague Professor Yanis, and also my colleagues from the University of Zagreb and Faculty of Transport Sciences, and our dear friends from Friend Engineering, an engineering company from Italy and Spain, I think. It's okay to say it like that. So the research study was done, was commissioned by the Commission. So we did the work for the Commission. Then this work is now published, and there are links here in this slide that you can copy or screenshot, and you can access the full documentation about the methodology. So going forward, just a little bit of a context. So this methodology is endorsed by something called the EGRIS group, which is the Expert Group on Road Infrastructure Safety. It's a group of member state representatives, which are, let's say, helping the Commission defining the policy levels. And this methodology was presented there, and it was adopted. And now we can say that this methodology is, it can be officially used to deliver what the requirements of the directives are asking. So it is a guidance. So, but the Commission's kind of wants everybody to use the common methodology in a sense that they can compare the results. It is compliant with the directive, of course, and as I said already, it can be used on the Trans-European network, which can be also, which by the directive should also be including the primary roads, which are all the motorways in a country, and other primary roads which are of a high significance. Also, the directive is saying that all of the elements of the directive, including road safety audits and road safety impact assessments, should also be performed on the road network, which is funded by the EU money. So in terms of the EU, this is the context. The methodology itself has, as we mentioned earlier, also a reactive and a proactive component, and then at the end, integration of the methodological results that can be used to provide the overall rating. So first, let's go into the reactive approach. The reactive approach is based on the crash occurrence analysis. It considers all of the road users that might be present on the road. It does not cover the tolls because in this sense, they are outside of the scope. Also, the tolling plazas and the tolling areas are as well outside of the scope. The process itself goes in 5 steps. So we have the identification of road types. We have something which is called the segmentation, then the data collection, then the metric calculation and the threshold definitions, and then the road safety rankings based on the actual crashes which are happening. So the first step in the methodology is to determine the road types and define the axes, the center lines of the roads which are being assessed, so that they can be used again for the identification and in the future for the comparison of the improvements or the change in the trends which are happening on the road. So in this sense, the methodology proposes that we divide roads in 4 main categories. So we have motorway which are rural, motorway which are urban, and primary roads which can be divided or undivided. So the type of the road, of course, can change along the same axis. So we can go from rural to urban and vice versa. But the primary road type should not change inside one's sections. So the identification of the exact points where motorway changes from urban to rural is not fully defined. So it's left basically to the judgment of the experts who are doing the classification in that sense. So now when we have that, when we have the road network, we also define sections and junctions. So sections and junctions are being defined separately. They can also be integrated in one, but this is depending on the approach which is being taken. So you can take in the segmentation the approach number 1, approach number 2, or approach number 3. Approach number 1 means that the sections that you divide your roads in also include junctions. Approach number 2 means that you can also separately assess road segments which are between junctions and junctions. And then junctions are defined based on the predefined dimensions which are described in the methodology. Or in some cases, as we saw while we will be delivering this study, that this might not be applicable to all countries, then the third approach is also feasible, where you can also define the dimensions or the types of your junctions that you want to use for the classification. It is very important that you should not mix the approaches to the segmentation. So if one approach is taken, it should be continued at least for the category, but it would also be good to be continued throughout the segmentation of the network. So yeah, the sections itself should be divided roughly on a homogeneous method, meaning that, you know, the same section should contain the same speed limit or the same terrain type or similar characteristics of the roads. I just have my clock here running, so I don't overdo the time. As I said earlier, tunnels and toll stations are excluded for this. It is also recommended to align the points, the segmentation points from the reactive and the proactive methodology, but this is something that we will define later. So also methodology defines the length, the recommended lengths for the reactive methodology, which for the rural motorways goes 10 kilometers plus minus 5 kilometers, and the urban motorways, which should be 5 plus minus 2 kilometers. So the maximum length should be around 7 kilometers. Of course, many exemptions can be allowed in case we lack the information about crashes, so we have some other issues which are relevant. After we have the segmentation, we go into the next step, which is the data collection. So in the data collection stage, we are collecting at least 3 years of road crashes. Those crashes should involve at least one casualty. It can be a fatal, severe, or slight injury, depending on how many crashes you have. But for the statistical relevance, it is always better to have more data, more incidents, so-called. So you might consider it is for the statistical purposes better to have also included slight injuries as well in the data set. The crashes should also be collected for the all road users, even cyclists, pedestrians, etc. For the motorways, we also need to collect the crash data. We have to know on which side of the road the crashes have happened, but for other types of roads, so if it's an undivided road, of course we can't have this information, and it's quite irrelevant because we are collecting for each segment of the road all crashes that happened regardless of the direction of the travel. Going next, so the ADT also, in order to get so that we can calculate the density and other parameters of the road safety analysis, we also need to have the ADT, which is the average annual daily traffic. It has been observed from our research and our study that most of the countries have sufficient and good data about ADT, at least for the motorway network and for the primary roads. So this also needs to be collected in a way that we need to have ADT per direction of traffic for the motorways and divided roads, and both directions for undivided roads. Also for the junctions, if you are taking the approach of rating the junctions separately, we calculate all of the vehicles which are entering and exiting the junction, and this is the total ADT, which is then used for the assessment of a junction. So once we have all this, we are preparing something which is called the reference population. So we are basically collecting all of the sections and the data from those sections and linking them based on the type and based on the values which were collected, and in a sort of a database which is called the reference population, and we mark down the segmentation approach that was taken to deliver this. With that, we go to the scientific part. So based on this population of the roads which are in a same category, same type, we define the upper and lower thresholds of what seems to be a safe and an unsafe road. This is done by using the Poisson method. There are formulas. There is an Excel sheet which is available for that, where you actually enter the data which is available, and then the Excel formula actually calculates what is the lower threshold and what is the upper threshold for the safety assessment. Once we have that, we are calculating then the crash rate for every section separately and the crash density, and those two factors are then used in the table to compare to the thresholds. In that sense, if your metric for a section is lower than the lower threshold, then we are marking this corresponding junction as high risk. If it's higher than the upper threshold, we call it the low risk. And if it's between the lower and the upper threshold, we call it unsure. So that's, let's say, a population of roads which cannot be classified as high risk or either low risk, so they are somewhere in the middle. And it then says that would be let's say all for the reactive approach. So the methodology and the RISM directive is asking to actually combine the reactive and proactive approach. So that's why in this methodology there is also a new definition of a methodology that is considered a proactive approach. And this methodology is, let's say, it is also taking into account all of the road users, but again, it is not applicable to the road tunnels and toll areas, but it is applicable to the bridges, and that's something which is of course quite important. So again, the steps in the proactive approach are somewhere similar to what we had earlier. So we have the, again, identification of the road types. We have the overview of the data collection and assessment. Then we have the segmentation, detailed data collection and estimation of reduction factors per parameters which are being used to evaluate the risk of a typical road. The roads are again divided into 4 categories: motorway rural, motorway urban, primary roads, divided roads, and primary roads, undivided roads. The data is basically being collected in 2 stages. So before the segmentation, we collect the so-called overview data, which is targeted to facilitate the segmentation processes correspond to the aggregated level of details. And after that, at the higher level of details, we are collecting data per section of the examined road and provide the requirement information for the implementation of the proactive assessment models. In that sense, it is a good practice basically to collect whatever data is possible, because you will see a bit later what type of data we are needing, and whatever data you can get, either designs in CAD file or paper format, or road estimate management data in form of a road inventory data, or any other GIS data that can be collected either through the road authority GIS systems or the online available tools like Google Maps or OpenStreetMaps are welcome and can be used to prepare the NWA surveys, but also it can also be site surveys. So that's something which is quite relevant. As you know, many of the countries already do have some site surveys, either for iRAP or for any other methodology. So those site surveys can actually be used also for this methodology. So the segmentation process itself involves dividing the roads into smaller parts. And here in the proactive methodology, we have two alternative segmentation approaches. So again, we can use the roughly homogeneous based segmentation, which is based on traffic volume and number of lanes, terrain types, and speed limit. And for this approach, the maximum section length, which is proposed, is from 2 to 5 kilometers. Or we can use a sectioning of a fixed lane, which is smaller. So in the methodology, we define 500 meters as an optimum. And in this case, the homogeneity is not explicit. So it can be just for the 500 meter length. Also, it is recommended that this fixed lane should not be much longer than this 500 meters. But in some cases, you might need to also do that. But as long as you describe what approaches you took, it should be fine, and you should be able to link it with the reactive approach. So here are some examples. So here on the left, you can see an example where an intersection or a junction would be defined. So you can see the start here down there of the dividement of the center line. And this is the axis of the actual intersection. So basically, from the start to the end of the intersection, we would call it a junction, and then in between we would have the section. So those locations we call the gore points, and they are defined by every country in the way that they think it should be done correctly. There are guidelines in the methodology on how you should be doing it. The other example here shown on this map is also the terrain type. You can see here rounded in blue. It's the flat terrain type. You can see that this road is going through the flat terrain, and then we have also hilly and mountainous terrain, which is also obvious from the maps. So the detailed data collection for the proactive method is also different for the motorways and primary and other rural roads. For the motorways, we collect those 6 attributes which are shown here. It's basically lane width, roadside curvature, interchanges, conflicts between pedestrian, bicyclists, and motorist traffic, and also traffic operation centers or mechanisms to inform the users for the incidents. For the primary or other rural roads, there are a bit more. So we are also considering shoulder types and passing lines and the quality of signs and markings. If we link that to the Annex 3 of the directive, the Annex 3 defines the indicative elements that are supposed to be used for the network-wide road safety assessment. And in this sense, we see here that because of the complexity of the collection of all of the 55 indicative elements within the EGRIS group and the expert group, which were delivering this methodology, it was decided that the methodology should stick, let's say, to the important ones and the ones that can easily be collected. So that's why from the 59 attributes which are proposed in the annex, actually for the motorways, the relevant ones are the 6, and for the other roads, if you look in the and of course some of the attributes which are collected in the NWA can also be defined as dual. So for example, we can have a attribute which is being collected that actually covers the 2 indicative elements of the network-wide road safety assessment. But overall, we can say that for the motorways, from the 59 indicative elements in the directive, we are using 19, and for the primary or rural roads, it's 22. So coming to the next step. So first, we have something which is called the crash modification factors. I'm sure you all know about that. That's basically a value which is derived from the empirical and scientific research on how what impact a certain element of the ROV infrastructure can have towards the severity and the likelihood of crashes. In this methodology, those crash modification factors from the international literature were used to define something that was called the reduction factor. And this reduction factor is basically nothing else than 1 divided by the crash modification factor, meaning that if you give a score of 100 to one section, and then you multiply it by the reduction factors based on the features that you have on the road, you will get the reduction factor in terms of safety for a road, considering that a value of 100 would be a perfectly safe road. So in this step, now I will just give some examples for the urban motorways, how the data collection and the crash modification and reduction factors actually work. So for example, for the lane width, so for the lane width, for the section which is being segmented, you need to collect the value of the width, which is measured from the edge line to the center line, and then all the way to the edge line on the right. Where you measure the width on several locations, or you collect this data from the asset management systems, and then you calculate the average width for the whole section, which is being segmented as explained earlier. Now, when you have this average width, you look into the table which is provided in the methodology. You select the CMF, and by using the CMF, you also get the reduction factor. As I explained, it just reduction factor is just 1 divided with the CMF. For the roadside, similar. So for the roadside, we are in this methodology using a bit of a different approach. So it is based on the percentages, and the percentages of the features which are present and the distance to the features which are in the clear zone or which are on the roadside. So you take the whole segment and you actually try to define how many what is the percentage of, for example, in this example, you have on the section length of 4 kilometers, we have a clear zone of 10 meters with 0 obstacles on the 30% of the network. So in the second row, we have again 4 kilometers, 5 meter clear zone. We have a concrete barrier, which is on the 20% of the road, and so on and so on. 6 meters series of rigid objects, which are covering 25% of the road. With that, again, we have the CMF table, and in the CMF, you can also, by again using the formula, calculate the reduction factor that will be used in the final step of the definition. Curvature, for the curvature, the situation is a bit different. So we measure the radius and the length of the curve, and then we have the formula that is used to calculate the CMF, and from the CMF also the reduction factor. And this formula is because it would be complicated to make a table for the curves. That's why the formula is used. For the intersections, again, gore points and the distance between the exit and the entrance and the exit ramp is being used to define the CMF. So the length of between the 2 gore points is used to define the CMF, and then from the CMF, again, the reduction factor, and the table is there, but also the formula is available if you are using spacings which are not fixed for the whole network. Just being a bit cautious of the time. Yeah. So also data collection. So we also collect the potential conflicts, and this is just the urban motorway example. So you will see here for this example, it is a bit simpler. So here we just define the sections where the pedestrians and cyclists do not approach the motorway, and then or they have a level separated or fully protected facilities, or potential conflicts with the vehicles. And this is usually for the urban motorways. It can happen, especially if you have gas stations or any other facilities which are present on the motorways. The factors, again, for the motorways are quite simple. So you have the reduction factor for the first 2 is basically 1, so there is no risk. But if you have a a potential conflict. As I mentioned, if you have people crossing the motorway, of course, the reduction factor is very high. Or in this case, the number is very, very low, but if you multiply 100 with 0.05, the result will be a very high reduction of the safety rating in the end. Also, the last attribute used for the urban motorways is the traffic operations center or mechanisms to inform the incidents. And this is one of the examples of this attribute, which is actually dual. So in the methodology, it's one attribute, but if you look at the annex, it's actually two attributes. So here we collect if there is this operational centers and mechanisms to inform users, or if they are not present on the road. And then we also have the corresponding reduction factor that we can link to those two methodologies. And now coming to the important part. I hope it's not too technical. I already explained a little bit about this. So we have a empirical value of 100, which represents, let's say, the perfect road. So if all reduction factors would be 1, we would get a perfect score of 100. But we multiply by all of the reduction factors that we got while collecting the data, and then the number that we get by multiplying is actually the score of the proactive assessment of our road. And then we assign those roads and we put them in the table. So for motorways, if we get the score which is higher than 95%, we can say that this road is safe. If it's between 65 and 85% of the maximum score, we call it yellow, or we call it as intermediate risk. And going to the high risk, if it's below the 65% of the total scoring, then the road is considered a high risk and is being colored as red in the table. For the primary and other rural roads, the bands are a bit different. So it's up to 80% we consider green, 50 to 80% consider yellow, and less than 50% we consider high risk. So those roads are basically what we want to see in the future. And then coming to the integrated approach, as you can see here. So now we are, in order to define what the European Commission is asking for us and the directive is asking for us, we have to define the roads in 3 classes. We need to define the roads in very high priority, and you know, the roads that need to have, let's say, a very immediate investment in terms of improvement of the safety. But you can see here that actually the reactive component has a very strong influence. So basically, if you have a road which is high risk in terms of the assessment results, then independent of the proactive result, you can have a low risk in the proactive, but a high risk in reactive. The road should be categorized as a very high risk. So this matrix here basically is a combination of the proactive and assessment, the proactive and reactive assessment, but with the highest bias towards the reactive methodology, which in a sense is still quite relevant, because of course we want to first fix the roads where most people are getting killed or injured in the process. So just looking how it looks on the section base, so you can see here that reactive sections are usually longer, and then we have the proactive sections which are shorter, and then we basically combine, based on the metrics that I showed earlier, the ratings, and then the integrating part is actually delivered to the smaller segmentation that was delivered in the proactive methodology. It can be, again, different approaches in different countries, because in Europe, as you know, we are sometimes have very different approaches to how we define our roads and our segments. So that's why it is left basically for the experts in each individual country to define. But the important thing is, of course, to link the ends and the beginnings in both reactive and proactive approaches, so that you can actually provide the good integration. And that would be all. 1 minute overdue, sorry for that. And if there are any questions, I give the floor back to Franco and Samar.
Thanks so much, Marco, for your presentation. There are indeed some questions. Let me start with the first in the chat from Luca Lotero. The question is, are road markings taken into consideration for the calculation of the reduction factor or for the level of safety of roads?
I'm sorry, Franco, I did not hear the question well.
Oh, okay. I'll read it again. Don't worry. It says, it's from Luca Lotero, and it says, are road marking taken into consideration for the calculation of reduction factor or for the level of safety of roads?
Yeah, they are taken, but not for the motorists. For the motorists, they are considered to be safe mostly in Europe. So for the other type of roads, which are primary roads and rural roads, it is taken into consideration.
Thanks for that, Marco. And then we have one other question from Brendan. But Brendan, I would prefer if you would you can ask the question yourself instead of me having to read it because it's quite long. So you should be able to speak now.
Thank you very much. I hope you can hear me. Franco, if you
Yep.
can confirm, excellent. I actually had two questions, so I hope I'm not kind of abusing my privileges here. So the first question related to the connection between the network-wide road safety assessment and the targeted road safety inspections, which are planned and indeed introduced in the new iteration of the RISM directive. And it wasn't very clear to me from the presentation or the handbook how one related to the other and whether this was left to the appreciation of the member states. My second question concerns, as we think about the proactive assessments and specifically the risk factors for vulnerable road users, cyclists, pedestrians, and so on, they are, obviously they are included in the overall calculation, but there isn't, to the best of my understanding, a dedicated assessment for those categories of users like there might be for iRAP. And is there a risk, therefore, that they might be diluted when it comes to calculating the overall proactive score, if that makes any sense? Thank you very much.
Yeah, absolutely, Brendan. Thank you for these questions. Yeah, so the targeted inspections are basically something that we used to call in the old directive the road safety inspection. So it should be on the indication. So let's say the NWA should be used for screening. We should identify which roads are above the threshold, above the risk, and then a road safety auditor should be commissioned to actually do the road safety inspection, which should be the targeted inspection. This is how we are doing it in Croatia, at least in the legislation. It's not fully operational yet, but that's the way that it will be done. So we basically will do the screening, and then based on the screening, there will be a plan on how to do the targeted inspections across the network. Regarding your second question, yeah, it's also a very valid point. Directive calls for inclusion of VRUs in all of the procedures. The problem with the assessment methodologies with the VRUs is the lack of proper accident data and the CMFs. So if you look at the scientific research on this area, there is very few information about how actually infrastructure affects the safety of VRUs. And I'm not talking here about the motorcycles and the guardrails, because we are more or less clear in that sense, but separate cycling lanes, sharrows, and those type of infrastructures for cyclists and pedestrians are quite not investigated yet. So it would be, in a sense, very hard to make a methodology which would be based on the scientific facts. So that's why in this first, I would say, first version of this methodology that might be updated in the future, I guess, we stick to the things that are known and adopted by the scientific community.
Thank you so much, Marco, for your question, for your answer, sorry. And also during your presentation, Wafai asked he wanted to raise a question. So it would be the appropriate moment now. You should be able to speak now, Wafat. Yep.
Yes, I would like to thank you all, especially Mr. Franco and Engineer Summer, which I knew, and I hope she remembers that when she came to Jordan. I think we are the only people that joining this great and very informative presentation regarding iRAP Euro. We are from the Arab country, from Jordan, and I would like to thank the Associate Professor Marco for a very informative presentation. I have no questions. I have to read it carefully, if may we allowed to see it, the presentation, because it's well engineering presentation. Just to thank everyone, and I would like to say that if possible that we could be involved from the Arab countries. I know we're talking about iRAP Europe, but we are all interested in reducing number of deaths on the roads, and this is from the from 2020 to 2030, which is the goal for the whole world. So I just want to thank everyone, and I would like to say hello to Ms. Samar Abu Raad. I hope she remembers when she came to Jordan in the 90s and we met, and I hope for a future cooperation between Jordan and iRAP Europe for such a great presentation. Thank you all.
Yes, yes, Mr. Msais, now I do remember you. Thank you very much for participating today. Of course, you're most welcome. We are doing as iRAP work in some Arab countries, and now we just launched a very big program for Saudi Arabia, and some programs are done in North Africa. Please reach out to us, and we will see if we can do anything for Jordan. I know that you are doing a lot of good work, but whatever we can do to help, definitely we will be here. I will liaise with you separately. Thank you for your appreciation, Mr. Msais.
Thank you, Samar. Thank you, Marco, also for having the time today to have this presentation. We had some unresponded questions due to the time. Richard, I wasn't able to allocate that question, but if you reach me through email with that question, I can totally redirect that to our presenters, and they can answer by written, and there's no problem. I will forward that to you.
Franco, I can answer very quickly to the question to Richard. Some of the countries in the EU actually, yes, do not publish their assessments, their reactive mapping, including the crashes. But some do have them, although it's not published as an European approach, but they are done separately. I really welcome the offer into looking in the UK, and we do work a lot and with the UK Road Safety Fund, who is a big partner for us. So thank you for sharing, and we definitely look up to the methods you used in the UK. Thanks again.
Thanks so much, Samar, for that. And as I was saying, a big thanks, Samar, to Marco, and to all of you who were able to spend an hour with us in this presentation. Remember that we always love receiving feedback, and especially if you have any topic in mind that you would like to be covered in next EuroRAP lunchtime seminar editions, you can let us know. Our next edition for this EuroRAP lunchtime is going to be in May. We are going to confirm the specific date and time soon. Well, the time is this time because it's lunchtime, right? But we will confirm the date soon. And also, I would like to let you know and invite you to our RAPKNOWLEDGELIVE session. The session on the 18th of April is going to be the first session of this series of webinars. The plan is to meet on a monthly basis and gather to discuss and present the latest developments in regards to road safety and general knowledge in regards to road safety. This very first presentation, it's going to be on the youth engagement app for safer school journeys. We will discuss how the app works, how it's capturing, the student experiences, and how it's being implemented in a specific project. We will have Rafaela Machado and Shana Lukasiv on behalf of iRAP, and Trang Trong will join us on behalf of AIP Foundation from Vietnam. So we are really looking forward to having them presenting on the youth engagement session. And as I was saying, if there was something that we didn't respond, or if you would like to reach us, here is my contact details. You can send me an email and I can, well, either answer you or redirect that to the person who can answer you better. So really, really looking forward to having contact with you. And thanks again. I hope you spend a great afternoon today. See you guys.
Thank you, Franco. Thank you all. See you.